So, here is one more problem on pure rotation. So, let me first tell you what exactly do I mean by pure rotation, because I do not know if it is a standard word. A ceiling fan rotating about a fixed axis is undergoing pure rotation. And what do you think the particles of the fan are doing when the whole fan is rotating about a fixed axis? All the particles belonging to the fan are undergoing circular motion. Fine. So, that is where I think you will for the first time come across rotational motion and circular motion. A student will clear cut be in a position to understand the difference between circular motion and rotational motion. Remember, the fan as a whole is rotating there about a fixed axis, whereas the particles belonging to the fan are undergoing circular motion. And another thing is, circular motion was a part of translatory motion, and now what we are discussing is rotational motion. So, here there is a problem on pure rotation. Let me read it for you once. A solid cylinder of mass 50 kg and radius 0.5 meters is free to rotate about a horizontal axis. Oh, let me warn you one more small thing. While you are solving the problems on rotational motion, read the problem very carefully and try to understand the plane of rotation as well as the axis of rotation. How is the plane of rotation and how is the axis of rotation? So, here is a problem on pure rotation, and let me first tell you what exactly is this pure rotation. When a body is made to rotate about a fixed axis, you can say that the body is describing pure rotation. And this is, I think, where a student will come to know a relationship between circular motion and rotational motion, because when a body is purely rotating about a fixed axis, all the particles belonging to the body will be undergoing circular motion, right? And also remember that circular motion is a part of translatory motion, and that is the reason we must have taught it to you long back, right? And what we are teaching you now is rotational motion. So, here there is a problem on pure rotation. Let me read it for you once. And there is also another small warning which I would love to give you here is in solving all the problems of rotation, kindly read the problem carefully to understand the plane of rotation and the axis of rotation. Many times the plane is horizontal and the body is rotating about a vertical axis, and sometimes the plane of rotation is vertical and the axis is horizontal. So, let me read it here. A solid cylinder of mass 50 kg and radius 0.5 meters is free to rotate about the horizontal axis. A massless string, see, free to rotate about horizontal axis. You can underline this particular word. A massless string is wound round the cylinder with one end attached to it and the other end hanging freely. Tension in the string is to be found so that an angular acceleration of 2 revolutions per second square is going to be produced. Now, there are a little bit of conversions which you are supposed to understand. The angular acceleration is given to be 2 revolutions per second square, and we will convert it into radians per second square. Fine. So, 2 revolutions per second square can be written as 1 revolution corresponds to 2 pi radians. So, it should be 2 into 2 pi radians per second square. Fine. So, we got alpha there, and let me draw the figure which represents the problem. See, this is the solid cylinder, this is the horizontal axis that he has given. One end of the string is tied to the cylinder, the other end is hanging freely, and let me mark the tension as T. And remember, this is the radius of the cylinder, right? And because he has given that the cylinder is solid, you can even underline this also. This helps you understand what should be the moment of inertia of the body given. So, it is a cylinder and that too solid. So, the moment of inertia of a solid cylinder is m r square by 2. Moment of inertia of a solid cylinder is m r square by 2. M r square by 2 is also the formula for the moment of inertia of a disc, and I hope you all agree that basically a solid cylinder is a stack of discs. If you keep the discs one on top of the other, that is going to form a solid cylinder. So, I is mr square by 2. Let me put the value of I as 50. R is given to be 0.5. So, 0.5 square divided by 2 gives you the moment of inertia, and that makes it 50 into 0.25 divided by 2, that is 25 into 0.25, which I think is 6.25. So, that is the moment of inertia, and now the equation has to be tau is equal to I alpha. I is 6.25, alpha is 4 pi, right. See, he had given 2 revolutions per second square, 1 revolution corresponds to 2 pi radians. So, 4 pi radians per second square is what we have got as alpha, and divided by this is I and this is alpha, alpha is 4 pi, fine. So, this is the torque that you need, and this torque is generated by the tension in the string, and that is given by T into R. I hope you agree there. See, the tension is the one which is going to produce the torque about the axis of rotation, and you can give it as tau is T into R. So, T into R is equal to 6.25 into 4 pi, fine, and T is 6.25 into 4 pi divided by R, and that R is 0.5 again. And if you simplify this, you are going to get the answer as 157, and that makes your option D perfectly correct.